One thing I thought about covering for a while, I thought about it because it's real controversial and a lot of people have a lot of opinions on it, and I have my opinions and they might differ from other people's, and I don't know if it's exactly too relevant to what a lot of people do to tune their cars nowadays, but it's front roll centers. So I decided after a week of thinking about it and some stuff came up and some ideas and some talking about it, I decided to make a video on front roll centers. So let's roll the intro and let's get into some front roll centers. I've spent the last 30 plus years working on race cars, building race cars, and racing cars. And I'm here to help you better understand racing technology. Okay, front roll centers. Where to begin with this? I guess I would like to begin with there are actually two front roll centers in your car. I would consider them two. One is a kinematic roll center, and that's everything that we've been taught up till now, basically. It is the intersection points of your physical suspension mounting devices in the front and the load that goes between the center of the contact patch and through the intersection of those devices. Then there's another roll center, which I call the elastic roll center, and that is happening through the springs, and it's a combination of both that I think gives you your true roll center. To actually find this true roll center, I think you'd have to have a mind similar to Einstein. That's why, in my view, I don't pay a whole lot of attention to it. I pay more attention to where those intersection points first initially meet in a front end for your suspension connection points, and that is an instance center. I pay attention to that, and the elastic roll center separately a lot more than I do trying to figure out how the actual roll center is figured in the front end of the car. But we'll get into that a little bit. I got some diagrams I want to draw and stuff like that. So I guess I want to start off with the kinematic side of it, because that's what we've always been taught. Is the roll center is a kinematic center of the car that the car rolls on. And it's basically if you take your upper control arm and extend it towards, let's say, the right front. Take your upper control arm and extend the point all the way through the ball joint and your inner pivot, I call it. You'll get a line. You draw that line through. Then you take your bottom through the ball joint, through the pivot. Where those two pivots land is your instance center. Then you do your left side, and you make a diagram of this. And then with the diagram of this, you'll have your two instance centers. Well, if you draw a line through your instance center to each contact patch, where those two lines intersect is considered your kinematic roll center or your force-based roll center, I guess. People have a lot of different names for it, call it something. But that's where we all learned, that's where we grew up with roll centers. The elastic roll center is something I've learned within, well, it's been a while for me, early to mid 2000s. The elastic roll center is something that happens to the springs when one spring is softer and one spring is stiffer. You'll have an unloading on a spring a little bit and a loading on the other one, and that will determine that unloading and that loading between the differences in the springs will put you at a different roll center. And I'll go through that a little bit more on another drawing board project I got here. And we'll explain that a little bit further because that's a little bit controversial. Not a lot of people talk about it. I don't think a lot of people subscribe to it. And I've never heard it outside of that Formula One teacher's realm. I've never heard dirt people talk about it. They talk about soft spring there or stiff spring here and stuff like that, but never how it equates to a roll center in the car. And it's the focus or the combination of these two and how they move that I think actually determines your true front roll center. The best way I can show this is over on the drawing board. So let's get some diagrams together, go over on the drawing board, and I'll try to explain this whole theory the easiest and simplest way I can. Okay, this is the diagram we all kind of grew up with. We all kind of been learning for years where front roll centers are. This is what I call the kinematic roll center in your car. Basically, you have your upper and lower control arms, and if you extend those, you'll get an instant center in the front where those intersect. And you'll have a left and your right instant center. Then what you do is you take a line and you draw it from each of your instant centers to the opposite tire contact patch. And that will give you what I call a force line or whatever. I think a lot of people call it a force line. Where those two lines on my diagram here, it intersects over here. More than likely it's going to be closer to the center of your car towards the right front. But just the way I drew my goofy diagram here, it ended up over here. But anyways, this is what is considered your front roll center in a kinematic state. And everything your car technically will roll around that front roll center. If it's in the middle of the car and you get your force lines to intersect, then the car will roll out of the right front, on the left front, it will roll around that point. That's the force line intercept center. If you get some front roll center software, I had the Mitchell program for years, but it's been years since I've even opened it. I don't even have a computer that can open it anymore. I'm on Mac totally. But basically, you can put all this stuff in there. What I used to do is you put your car on ride height, bars, and then I made some steel things. I took the wheels off and I made some steel stands, and that would mark the center of my tires, and I bolted them on the hubs at ride height, so your car is basically sitting there with no front tires on it, no front springs, at ride height, everything all rigid. And each software program has a different way of measuring the car. You go through and you measure all these points and you put it in the software, and it figures your front roll center for you. And then you can take the software, you can roll it and dive it and move it around. It'll show migration as your car rolls, and as your car dives, the roll center will migrate left to right. Most of them do. Some of them don't. If you have a very consistent car with the right angles and everything left to right, and you can get that roll center to stay static, then that's what you do. Where it should be, where that roll center should be, is black magic. Everybody's got their own opinion, and that's why I don't get into front roll centers a whole lot. I'm just showing you the difference in how you kind of figure them. if you decide to go down this route, I don't think it's necessary for an average racer to go through this. But if you decide to go down this route, there's a lot of learning here, and you'll learn a ton. And I always had fun with it back when I used to do it. But this is how you basically figure kinematic front roll center. For the elastic front roll center, I never had such a pretty diagram. I always just kind of explained it, and I haven't done a whole lot of it. But elastic front roll center is something that will go through your springs. It'll show body roll, it'll take up, but there is a roll center there. Let's see something once here. Let's just start out with basics. Let's say you have your left front spring over here. We're looking at towards out the front of the car, and this is your left front. And you have a right front spring over here. Now when weight transfers over to here, and you have, let's say, your car here, this, if your springs are equal in weight, let's say you have a pair of 500s up here, and your car rolls off one spring and onto another, now your kinematics will come into a little bit different play. That's why all this stuff works. But if, let's say it's just two springs with a weight on top of it, whatever weight comes off of this will go onto this naturally, right? Just basic weight transfer. So this will extend a certain amount, and this will compress the same amount. It'll put your front roll center elastically in the middle of the car because one's extending and one's compressing at the same time. So the car is basically rolling around a center point. Now let's say we have another set of springs, a little bit more common to what we got going on now. And we have our force, or have our weight section here. This is our left front. This is our right front. Let's say this is like a 550-pound spring. And let's say we stack a spring over here, and it's a 200-pound spring. Now, when weight transfers, let's say you're getting the same weight transfer, whatever comes off here, maybe this will only extend a 1/4 of an inch. But this will compress with that same amount of weight because the 200 is a lot softer. This will, with the same amount of weight coming off of here and the same amount of weight going over here, this will compress more. When we go off of here and onto here, that will technically move your roll center towards the left front of the car, because the car is going to want to pivot, if you can picture it, compress here and extend here. But since this is stiffer and this is only extending a 1/4 of an inch, and this is the actual center line that this thing is going to roll on, is actually going to move left. And it's going to roll like this, right? I mean, just naturally, put a soft spring in the right front, we can watch that right front collapse. So a roll center, an elastic roll center, will always migrate towards the stiffer side. Where this becomes very interesting is when we get into the fact that we start stacking and locking out and then putting bump stops on things. Now let's say we have our left front spring is, let's say, back to a 550, And then we have our right front spring. And that starts out at a 200. And then we're going to set it onto a 500. We're going to lock out the 200 at some point. When it gets down far enough, we're going to set it onto a 500-pound spring. Well, our theory on the elastic roll center is saying that the roll center is going to move left because of the stiff spring here, and right, or because of the soft spring here and the stiff spring here. The roll center will move towards the left. But now, once we get that thing down and we lock out that top spring, and we're going to set that car onto a 500-pound spring. Once we set that car down, the differential between the front springs is a little bit, but not much. So this roll center now, technically, once we set that car down, it's going to migrate to the right and get closer to the center line. Actually, it'll be a little closer to the left because this is stiffer and the 500 is softer. But it'll be closer to the center line than the original stack spring. But now we're actually going to set this thing down onto a 500. We're going to have a bump stop on here. So let's look at how that will play out. I'm thinking most of you guys are probably already figuring what's going to go on, but let's draw a diagram anyways. Let's say you have your left front at a 550, and you have your right front stack at a 200. Oops, forgot to put my spring up there. A 200 and a 500. And our roll center starts out here. Our car starts to roll. But then now let's put a bump stop in here. So we're going to lock it out, and then we're going to have a bump stop on that shaft so we don't get too far down. So what happens is, and we'll have a bump here. What happens is, because of the 200 to 500 stack, the roll center will start out on the left side of the car. Soft spring, stiff spring, goes down. But now we lock out that 500, we lock out that 200, and we set the car down on a 500. That roll center will move towards the right. Now we go through and we set that thing down onto a bump stop, and maybe that bump stop creates a spring rate at 8 or 900. If it's a stiff one, you know, who knows what that bump stop, with the overall bump stop spring rate will be. That's why we got those cool new spring deals. Anyways, once you hit your bump stop here, this thing is, I mean, and you technically, let's say you have, it turns out to be 1,000-pound spring rate once you set that thing onto a bump stop. Maybe it's a bump coil or a bump rubber or whatever. 1,000 pounds of spring rate on the right front. Now that is stiffer than the left front here. So now the actual front roll center, when you set that thing down, the elastic roll center will be moved all the way over to the right. That's where the conundrum with the where is the front roll center is. Are we talking about the kinematic roll center? I think we still need to add in the thoughts of a spring if you want to talk true roll center. That's why I don't like getting into it too much, because there's too much variation here when you start talking about true roll centers. That's why my biggest thinking is with it is the force produced. Let's go back to our original diagram here. The force produced by the intersection or the instance centers I think puts a traction in your car almost like a J bar in the back. And where these intersection points, sometimes when your car rolls, if they end up above or below the ground, makes a big difference when the car rolls. So basically, I've been subscribing and basically concentrating on the instance centers and then considering the compression in the roll by using my mind around what happens with the elastic roll center as a car rolls, especially when we get into this bump stop thing and that thing migrates and sits down there. It does some really strange stuff to the car sometimes, I think. That's why I often just separate it. I don't even think about the kinematic stuff anymore because it gets too jumbled and complicated. I think about it as instant centers and then spring and elastic centers. So I guess if you're looking for recommendations on roll center software, the stuff I always used to use is the Bill Mitchell system, Bill Mitchell program. When I went to that class with that Formula One engineer, he was developing his own at the time, but he still used the Mitchell software. The two NASCAR teams that were there was Penske and Ganassi, and both those teams used the Mitchell software. So that was the creme de la creme. That was top of the line. That's what I had going in there. I had read about the Mitchell software years before that. So that's what I had. And that's probably about the best there was at the time. I know Performance Trends. I had bought the Performance Trends one back in 98, 99 maybe. Somewhere through there I was playing with the Performance Trends one. I'm sure it's gotten a lot better. I just looked it up. They still have it available. But to tell you the truth, if I were to have a certain allotment of money, Roll Center software is not something I would be spending it on as far as a tool to help you figure out your race car anymore. I don't think it's necessary. I think if you're looking for tools to help you with your race car right now and get you faster, the first thing you need is a spring smasher. The second thing you need to get into, and I think, is shocks, and get yourself a shock dyno. Does not have to be, actually, I don't like the computerized ones. I like the AccuForce one. I think Keith Berner over there probably builds about the best, and you can see once you get working with it, you'll see a lot with it that I could never see on the computerized ones. But yeah, use the AccuForce stuff. I like the AccuForce Spring Smasher. I like Chad Weir's Spring Smasher. He builds a good one. Actually, I think Chad and AccuForce work a little bit together on it. Um, but they both build quality pieces. Either one is great. Like I said, the shock dyno, and then AccuForce now has a data acquisition single channel data acquisition deal. You bolt it on your car, you bolt it with your shock and spring, and you go run the thing around single corner, maybe two channel. It'll have a weight load and a linear potentiometer that'll bolt in there too. So you get a height of a smash, and you'll also get a weight load on the top bolt. That one is, I think, critical to figuring out where your car is dynamically if you got a little money to spend. I would not take my extra money and spend it on Roll Center software anymore. If you have a lot of extra money and you got a lot of extra time to put all that data in and measure cars, have at it. But the big thing guys need to spend their money on now is, like I said, a shock dyno. Get learning on shocks. Learn as much as you can on shocks, because the more you send your shocks out to the shock guys, those shock guys got a ton of customers. Anything you learn or they learn on your shocks will get put into other shocks. That's why it's really important to kind of get leaning on yourself for shocks and get maybe thinking about doing your own shocks. So I would get a shock dyno, I would get a spring smasher, and I would get that 2-channel or whatever Keith over there has at AccuForce for that data acquisition, that mini data acquisition system through him is an awesome deal too. So if you like the video and you want to subscribe to the channel and ring the bell for notifications, the next time I get a video coming out, it'll notify you. Nothing spammy through email or anything, but it should notify you when you log into YouTube. So just subscribe to the channel, ring the bell, and I'll see you in the next video.